Hello everybody, this is my phys212 project, an optical analogy of quantum tunneling by using photon attenuation effects of the light. And my name is Anıl. My experiments I related quantum tunneling phenomena to photon attenuation effects because they both follow similar mathematical trends. So in quantum tunneling, when you send a particle or wave here to a barrier, its probability to transmit the other side exponential decays inside the barrier, and as it gets thicker and thicker, it becomes harder to transmit the other side. As you can see here, there is an exponential decay pattern, and we have the same effect in the photon attenuation. We measure this by looking at the intensities. You can see here it exponential decays as barrier gets thicker and thicker. This is the thickness of barrier and this is the number of barriers. This is the absorption coefficient and this is the initial intensity, and it will get there will be less intensity as there are more barriers. And this is the number of slides. These are our equipments to perform the experiments. We use a red laser. At first we used a green one, but it was too strong, so we had to change it. We used microscope slides. We used at first thicker ones, but they did not give as good results, so we changed them to this. Two screens to record the intensities, and a photodetector. We used our phones to measure the intensity of light, and polarizers to reduce the intensity of light to be able to measure them properly. This is our experimental setup. Here is our laser, and there are polarizers here. There are microscope slides we stabilize them, and there are two screens. This one records the transmitted intensity, and this one records the reflected intensity. This was our previous green laser, and we didn't use it. This was us performing this experiment with the green laser. You can see the white circle here. This means that the intensity there is too high even with the polarizers. It's too high to measure, so we didn't use this. You can see it. There is a white dot on the screen. We used the MATLAB code to measure the intensities. This was with the intensities with the thicker glass. We didn't use them, but I include them here anyways. This was us performing the experiment with the red laser. You can see there are no white dots on the screens, both screens. So our data will be more accurate by this way when taking the photo with the photodetector. So this was our results with increasing stacks of microscope slides. The intensity will be decreasing transmitted intensity, and more light will be reflected to the other screen. This was expected, but there were anomaly in the 40 stacks experiments. You can see here the error is very high. This is because the light was too dim to capture it with the same photodetector settings, so we had to change them, but this gave us very huge percent of error. So this is the cause of error there. But other than that, it is as we expected. Less light will be transmitted with the increasing number of stacks. This is our transmission ratio plot. It will be decreasing as we expected because there will be more light reflected and the denominator gets larger, so it will be decreasing. This is a theoretical trend. It somewhat follows a similar path, so it is accurate enough with the constraint we have. Our photodetector was our phone, so there expected to be some errors, and it still follows similar trends, so it's accurate enough. And this was our experiment. Thank you for listening.